Okay, so yesterday we looked at solving quadratic equations by taking a square root, right? And so when we have something that's squared, in this case x plus 3, then we can use our square root to find both solutions, right? Because taking a square root is going to split this into the square root of 8, which simplifies to 2 root 2. So if I subtract a 3, I get this kind of strange looking answer, negative 3, right? I'm going to put that negative 3 first, plus minus 2 root 2, okay? And this is really two different solutions, right? This is when we take a negative 3 and add 2 root 2, and we take a negative 3 and subtract 2 root 2, right? And so these solutions are zeros of our quadratic, or if we were to graph this on the plane, we would get our two zeros here, right? Where one of these is negative 3 plus 2 root 2, the other is negative 3 minus 2 root 2, and I'm just realizing this parabola should be on the other side of this y-axis, maybe like somewhere here, right? And so sometimes this is the most exact we could get, right? When we have solutions that don't simplify down to integers, okay, which is okay. So one way, the first way we learn to solve a quadratic is to factor it, right? And now that we see if we can get a perfect square, we could also use square roots, okay? And so this method today is a method for taking quadratics that aren't perfect squares and forcing them to kind of become perfect squares, okay? We call this process completing the square, right? And just a quick recap, our perfect squares are these polynomials, right? A plus b squared, a minus b squared, oops, is equal to a squared plus 2ab plus b squared, and then a squared minus 2ab plus b squared, okay? And so this is something we learned last unit, but it's kind of the theme of today, okay? So I'm going to erase all this. And let's look at our first example, okay? It's going to seem like a really long process, but if you do it a couple times, you'll get the hang of it, I promise. So let's just put this over here. So solve 2x squared plus 24x minus 90 equals 0 by completing the square, okay? So the first thing we want to do when completing a square is take our quadratic minus 90 equals 0, right? And we're going to plus bx plus c. We want this to have a coefficient of 1, okay? Because that's already a perfect square, okay? Because we're gearing up to make this a perfect square. So in this case, I'm going to take this and divide the 2 from everything. And this becomes x squared plus 12x minus 45 equals 0. And actually, I'm gonna modify this a little bit. I'm actually going to make it so we want this constant on the opposite side, okay? And I left a gap there, but... So in this case, we're also going to add the 45. So we want x squared plus 12x equals 45. Okay, and here's why we do that, right? This kind of leaves this blank here on the left side of my equation because we're then going to figure out what piece here is going to make this a perfect square trinomial, okay? And so if it follows our perfect square, this is going to be a squared plus 2ab plus b squared. And so really, if we can figure out what this b squared should be to make a perfect square, we can make this side of the equation a perfect square, okay? And here's what that looks like. The first thing you're going to do is you're going to calculate b over 2, right? And the reason we do b over 2, it's not arbitrary. It's a squared plus 2ab plus b squared, right? That's our perfect square trinomial. And so really, to figure out b, we need to cut this in half, right? And we already know a is just x. So if we cut this in half, we get b over 2 is equal to half of 12, which is 6. And that's kind of our magic number that's going to make this a perfect square, right? So we're going to add b over 2 squared to both sides of the equation, right? So in this case, if b over 2 is 6, we're going to add 36 to this side of the equation, right? And that's completely okay because as long as we do the same thing to both sides, it's still an equation, right? And so what that's going to do, it's going to complete this square. So this factors to x plus 6 squared, right? And we get equals 45 plus 36 is 81. And so step 3, well, is to add that value to both sides of the equation. And then we're going to factor the perfect square trinomial, which we did right here, right? And now once we have it factored, we have this set up, whereas we can solve using the square root. So we're going to take the square root of both sides, and this is going to give us two solutions. We get x plus 6 is equal to plus minus 9, right? So solving for x, we get x equals negative 6 plus minus 9, which we can simplify further. Negative 6 plus 9 is positive 3, and negative 6 minus 9 is negative 15. Okay, so this parabola has x-intercepts at 3 and negative 15. So the biggest thing here is we remove the coefficient and move over the constant to make room for a complete square, right? So we have x squared plus 2a squared plus 2ab plus b squared. Essentially half of the middle coefficient squared is that number that's going to give us a perfect square. So half of 12 is 6, so we're going to add 36 to both sides of my equation. By doing so, this creates a perfect square trinomial that can be factored. We take the square root, plus minus 9, and we solve for x, okay? Let's look at another example. So, I'm going to move this 5 over here. Get t squared minus 8t is equal to 5. And notice how I'm leaving the space here because I know I'm going to complete the square, right? So to complete the square, I want half of negative 8. So negative 8 over 2 squared is equal to 16. So I'm going to add 16 to both sides. This is now a perfect square. T minus 4 squared equals 21. So I'm going to take the square root. T minus 4 equals plus minus the square root of 21. Okay, now if I could, I would, but there are no perfect squares we could pull out, so this is actually just fine. So our last step is to add 4 to both sides. So we get t equals 4 plus minus square root of 21. So it's important that we put that plus minus afterwards, because it kind of reads naturally this way. 4 plus root 21, 4 minus root 21. Okay. Cool. Let's look at this one. So we have ax squared plus bx plus c, or the c. We have the constant moved over. So all that's left is to get this coefficient equal to 1. So we divide both sides by 2. Get x squared plus 4x equals 60. So a squared plus 2ab plus b squared. So half of 4 is 2. So we're going to add 2 squared to both sides, right? So this factors to x plus 2 squared, a plus b squared equals 64. This is a perfect square. So we get x plus 2 equal to plus minus 8. So if I subtract the 2, we get x equals negative 2 plus minus 8. Okay? So this becomes, we have our solutions. X is at 6 and at negative 10. Okay? Now, I wish we were in class to talk about this, but if we look at this form of our solution, -2 plus minus 8, it not only tells us, gives us our solutions or x-intercepts, but it also tells us something right here, right? That -2. So if I were to just sketch this out real quick, kind of these solutions are telling me that if I have this quadratic equation, right, and I do all this to solve, it's saying that the zeros, or the solutions, or the x-intercepts, are 8 away from -2 in both directions. -2 plus 8, -2 minus 8. So if we're at -2 here, if I add 8, I get to 6. If I subtract 8, I get to -10. I know that these are my two zeros, but that also means my axis of symmetry is at that -2, right? And so it's centered, right? And so we could even find the vertex. If I just plug in -2, I can figure out where y is, right? I can also kind of get a sketch here that my function looks probably something like this. So -2 plus minus 8. Here we have the plus 8, the minus 8. Okay. I don't know. I think it's important to see the picture, right? Okay. Your homework is going to be to finish these 4 examples. And you could ignore this last question. We're going to get to vertex form in a little bit. I switched the order around this year, but I think I like the old way we did it. Oh well.